Hi guys, welcome to Learners of Calculus, and today I'll be introducing you guys to derivatives. So, what is a derivative? The derivative of a function is the instantaneous rate of change of a function. But before we get into that, first let me introduce you guys to the concept of average rate of change. So, average rate of change. So, A or C, average rate of change. So, what is the average rate of change of a function? The average rate of change of a function. So, let's say we have hmm, out a random function that goes like this, right? Let's say we have b and we have just zero, right? So over here, this is going to be f of b, and this is again just zero or f of zero. So the average rate of change of this function from 0 to b would be f of b minus f of 0 over b minus 0, which is just equal to, uh, actually, I'll just erase it. Yeah, which is just equal to f of b minus f of 0 over b. Okay, now let's get an actual example of this. So, for example, if we have the function x squared, right? Let's say we choose 9, and then again, 0. So we're going to do f of x is equal to x squared, right? So we're going to do f of 9 minus f of 0 over 9 minus 0. So this is going to equal to 81 minus 0 over 9, which is equal to 9. So in this case, the average rate of change would be 9. And so basically what 9 is the slope from 0 to, or well, from f of 0 to f of 9. And basically the slope, yeah, so in this case it would just be 9x, which is the function of the average rate of change, I guess. Yeah, but a derivative is not an average rate of change. It's an instantaneous rate of change. So what is an instantaneous rate of change? Okay, anyways, let me just draw a random function. Okay, so an instantaneous rate of change, uh, actually, let's think about it like this. So we know that an average rate of change is how, on average, how much the function differentiates between two certain points, right? So again, b and a. The instantaneous rate of change would be as a and b got closer to each other. So basically, if we wanted to find the instantaneous rate of change here, it would just be a line like that, because in this case, like it's pretty much going like this. Okay, let me make it even clearer. So over here, the instantaneous rate of change would go like this. Okay? So, basically, there's a derivative notation for this. And let me give you guys that notation. Let's try this. So, if we want to find the derivative of a function at a certain, let's say x naught, right? So, if we wanted to find this, right? This would be equal to saying the limit. Okay, actually, let me just draw this out first. So it's going to be a similar notation to the average rate of change, right? F of x naught plus h minus f of x naught over, well, we know it's going to be x naught plus h minus x naught. And these just cancel out, and it just turns out to be just h. Yeah. So limit as h approaches 0. Because what this would mean is that these points get ever so close, right? And when these points get ever so close, we get an instantaneous rate of change. Okay, so you know, this should start making sense for you, like bit by bit. So let me give you an example. Okay, so let's try the function x squared minus 3, right? And let's find the derivative at of when x equals 2. So basically for this, what we're going to do is we're going to do, again, the original thing again. So, so since 2 is the x naught value here, you're going to basically want to plug this in. So 2 plus h minus f of 2 over h. Yeah. So anyways, we're going to have to actually plug this in. So it's going to be 2 plus h squared minus 3 minus just 1, because if f of 2 is just equal to 4 minus 3, which is equal to 1. Again, oh yeah, and don't forget the limit as h approaches 0, otherwise it won't make sense. You're supposed to keep on, like, transferring this over, but, you know, for the sake of time, I'm not going to be doing that. So it should be 4 plus 4 plus 4h plus h squared minus 3. So this is going to be a 1 minus 1. This is going to be 4h plus h squared over h. This equals to 4 plus h. And if we take the limit as h approaches 0, then it's gonna equal to 4. And so yeah, there you go. That's your answer, and that's how to find the instantaneous rate of change of x squared minus 3 at, let's say, x equals to 2. Yes. And so after discovering this, it's important to realize that there are points where, okay, let's say you get a function, right? But there may be points for that function where you just can't find the derivative, and we call this being indifferentiable. So let me give you an example. Okay, let's say we have 1 over x, right? Well, now, tell me the derivative at x equals 0. But how are you going to do that? Because as here, the derivative seems to be approaching negative infinity. But then, oops, I mean, yeah, negative infinity. And then over here, it's also technically negative infinity since it's going downwards, right? So can you just say negative infinity? No, that wouldn't make sense. In fact, we can't even, like, if you were to try to, use this function for 1 over x, it would just not work, right? So let me give you guys a definition of when a function is differentiable. Okay, so a function f is differentiable at x naught, and only if f of x is continuous at x equals a, and limit as x approaches a from the left side of the derivative of f of x is equal to f of x is equal to the limit of x. A function f is differentiable at x naught and only if f of x is continuous at x equals a, and the limit as x approaches a from the left of the derivative of f is equal to the limit as x approaches a from the right of f prime are equal to each other. So this would mean that the limit at x equals a of the derivative of f has to exist. And so this is why I would now work for 1 over x, because we don't consider negative infinity to be existing because it's not an actual value. Again, infinity is just a theory and such, you know. So this is an important note. So continuity is necessary but not sufficient for a function to be differentiable. And so basically what this means is that yes, your function has to be continuous, but just because it is continuous does not mean your function is differentiable. So let me give you guys an example of this. Okay, let's say we have f of x is equal to the absolute value of x. Okay, now tell me what is the derivative here. Because it goes and then instantly this way. So instantly changes. Yeah, so there is no derivative there. And so this is a case of where continuity is necessary, but it's not sufficient. And so that's pretty much it for an introduction to derivatives. I'm going to be making more videos on derivatives to go more in depth. And thank you for watching as always. Peace out, guys.